So if not very clear, I can write it. Let me write it. So K equal to 2500, and for example, Newton meters. And the force is 20 cosine and 18 t. Okay. And the initial conditions, the x0 equal to 0.01, and meter initial velocity equal to 1 meter square. Okay, so for this exercise, we want to determine is the total response. Okay, so we want to determine okay, so right now we get the certain, we write it up the form. So the total response we know is the transient response and particular response. Okay, so the transient response is here for this term. That is combination of sine, cosine, and of the frequency omega nt. Okay, so that is the C1 cosine omega nt plus C2 sine omega nt. Okay, so here we need to determine omega n. So omega n will be equal to k over n. And for our n here, I didn't give that numbers. M equal to 5 kilogram. So that will be equal to 2500 divided by 5, 22.4 radian per second. We just get the numbers ready. Okay. So that is this one, and then also from here, and either you can redo from the scratch, but otherwise, if you like, you can simply plug in using our notice here. So say delta st and 1 minus r squared times. And again, here we are in cosine, so here you assume is cosine. Okay, and we are given the working frequency is 18, you're simply using the same form. Okay, so here we have to do other calculation. What is delta st? Delta st by definition is F now the static deflection, the magnitude of the force divided by the spring constant. So this is in newtons, okay. So the magnitude of the force equal to 20. Okay, how do I know that is 20? Because here that is 20, and here we are given is in newton. Okay, so K is 2500, so that will be whatever number that is. I didn't implement that one, but that's okay. Okay, and now what is R? R is the ratio of the frequency ratios. So our working frequency is given by here is 18, and omega n equal to 22.4. Okay, so that ratio we can calculate it at 0.8. So we got all the numbers ready, so we can put into here. That is C1 cosine 22.4t plus C2 sine 22.4t plus for this one delta st divided by 1 minus over r squared, and that one I do have a calculations 0.0226 and cosine 18t. Okay, so therefore, so here that is my calculations. 1 minus r squared equal to 0.0226, and that is in meters. Okay. And why this is in the length in the unit of the meters? if you remember, you can see that is coming from this one also be expressed by delta st 1 minus r squared cosine omega t or sine omega t. So this is the magnitude, amplitude of the steady state response. This amplitude pertaining to the x, so that reason why this term has the same unit of length. Okay, so here I put the unit here. Okay. So with everything here, then we are ready to solve for C1 and C2. So right now we have only two unknowns, C1 and C2. Again, when we're going to solve for those things, we have to solve it from the total response, not from the transient response. That is the only difference from what we learned we exercise in chapter 2. Okay. So here we take the derivative of xt from this term here, so that will be minus 22.4 C1 sine plus 22.4 C2 cosine, and this one is minus 18 times 0.0226 sine 18t. Okay, so with the two terms ready, then you simply plug in x0 equal to 0.01 and x dot 0 equal to 1. You're simply using the two informations and solve for C1, C2. So let me quickly jump into the results. C1 equal to 0.01, C2 0.0264. Okay, so plug in C1, C2, that is the whole total response. That's it.